Our next speaker is Tamm, the Salesforce CTO, directing technical product strategy across all clouds and divisions, and managing Salesforce's underlying multi-tenant kernel. Previously, he has been the CTO for CRM applications and the technical architect for Force.com checkout at Salesforce. Prior to Salesforce, he worked at OpenText, SAP Markets, and Calico Commerce. He has a BS in MEng from Course 6, Computer Science and Electrical Engineering from MIT. Please join me and welcome Tamm.
Oh, I got it. Okay, everyone. You can hear me? Thank you. I have a 4-month-old at home, so I'm going to be referring mostly to my notes. Didn't have a lot of time to prepare. Yes, I'm going to give a talk a little bit more about the future of AI, at least when it comes to software as a service. And unfortunately, my apologies, but since I talk about some research topics that we haven't actually turned into a product yet, my lawyers tell me that I need to put up this slide. Please make any decisions based on what actually products are had, and hopefully I'll keep the rest of it to a minimum. So artificial intelligence is going to change the world has been a standard cliche for probably 50 years. And when I was sitting in Marvin Minsky's Society of Mind class, what was that, 20 years ago now? No, it was 20. Class of 97, thank you. It was right after the second or third AI winner, I don't know, and it ran really hollow. We were learning not the hard AI problems of machine translation and understanding and replicating the mind, but soft AI like writing a good algorithm for playing anti-chess. And my roommate, some of you may know him, was a chess master, and so it made Deep Blue seem a lot less like artificial intelligence and a lot more like hundreds of years of algorithm tweaking by chess experts. There wasn't enough processing power, there wasn't a cloud, there was no way to replicate the mind, and there wouldn't be for hundreds of years. Now here we are, 20 years later, you're at this Future of AI conference hearing about these new learning algorithms, dramatically faster processing power, and immense amounts of data are allowing everything from hyper-realistic games, amazing health diagnostics, proficient speech understanding, and autonomous cars. Siri, Alexa, and Cortana are the names on the lips of consumers, and with them comes questions about how much information they have about you and privacy and reach. But for businesses and enterprises, they think about other things when it comes to bringing these new advancements in artificial technology. They want advancements to help them sell better, close deals faster, resolve service cases, better segment and market to their customers. They want to make their employees more efficient and raise the bottom line. But that has to be weighed against the costs. Compliance, security, days of residency, locality, malware, I'll get to that in a second, and risk. The complexity needing to ensure data quality and the expense of hiring a bunch of PhDs in a new statistical science, or an old one, can add up to millions of dollars. So for a multi-tenant software as a service company like the one that I work for, Salesforce, it means trying to build a product to help our customers serve their customers better and trying to minimize those costs. Other software as a service companies who aren't in the CRM space, they're still generally in the business of trying to make businesses work better, so they have similar issues. They want all the advancements of predictions and all the models without the costs. They expect their software to be smart. To do that, we have to build algorithms that build algorithms to do machine learning. We need a robot that is able to fix itself. So I'm going to go through 3 examples here of what it takes, but to bring AI together, you need to make sure that you have the right data models, you have the right processing power, and then you need to have quote-unquote big data. And so I'm going to go through the 3 sort of complexities that come up when you're in SaaS, which is the trust issues, you need to get access to the data, the meta-modeling issues around schema, and then how small and medium data can aggregate to hopefully become big data. All of these are very complicated problems, but I need to have a small digression to talk about multi-tenancy just to explain how complicated it is for us. Now, for the previous 3 speakers who are generally building things that are customer-facing or have a general homogeneous base, you can treat all the data from customers relatively equally. A person from the US who works for GE is the same as a person in the UK who works for Barclays, is the same as similar to a teenage girl in Hyderabad. The data can generally be co-located, and a data scientist is allowed to look at the raw data and fix the anomalies and tweak the models by hand to determine how to make search work better, or how to better sell to them, or how to make the vision better. They can see and track every movement and correlate those changes against deep demographic behavior that's derived from cookies or other behavior or massive sets of IoT devices. Salesforce cannot. Our number one value is trust, and as part of that trust is we cannot look at your data without your permission. Each tenant who uses our software gets their own space. Salesforce employees cannot see that data without permission. Think of Salesforce as a company that builds large skyscrapers containing condominiums, and each company that buys or rents from Salesforce, their data gets put in its own condo. We provide the water, the utilities, the power, but we aren't allowed to look inside your condo unless without your permission. That's your stuff, not ours. We even let you encrypt your data with your own keys. We can't see any of it without the keys present. And our customers can do all the data science that they want on their data, but we can't. So there's all the data, and we can't really see it. Now, as part of the first example, we do have security cameras at the entrances and exits. In a sense, we can track who's trying to log in, who's using the system. So we can see if someone has stolen your keys and is impersonating you. That's part of the application defense. Now, at Salesforce, I do lots of stuff, and I've been there 12 and a half years now. But I also manage internal platforms. We call it the kernel. And that includes a security analytics team with a team of data scientists whose job is to detect and prevent malware attacks. Malware is a particularly hard problem because it takes over the browser and makes it appear that for all intents and purposes, it's actually you who's trying to download all of your company's data onto your hard drive. It's software that steals the key to your condo and makes off with all your stuff, like your couch, while avoiding security at the front desk. But it's worse than that, more insidious, because for a multi-tenant company like Salesforce, it's not just one company that's targeted, but often a series of them across multiple data centers, allowing vital company data to be shuttled off to dark web servers around the globe. Now, we at Salesforce deploy state-of-the-art network intrusion detection. I'm sure you'll hear about that at the 5 o'clock talk. But when you're running SAAS, you need to develop a multi-tenant application security model to protect against this new malware as a service. Now, again, for all intents and purposes, they are you. So how do we know that they're not you? Because Salesforce can't look at all your data. Well, again, we're allowed to see who's coming in and out. We're allowed to see logins. We're allowed to see action patterns to see if something is acting off or strange. So for the first example, this has required us to develop some innovative anomaly detection algorithms around log mining in order to achieve first, real-time production performance, second, and very importantly, a low false positive rate, and third, a scalable platform for data volume and variety. So in a forthcoming paper, hence the forward-looking slide, we explain how we use principal component analysis to do this user-level profiling at terabyte to petabyte levels of behavioral logs. If you look at this chart, you'll see each dot, oh, the colors don't come out well, each dot is the behavioral pattern of a user, and we've color-coded it based on each tenant. Again, each company gets their own condo. So each of those forms a cluster, and each user inside can be an outlier for that cluster, but then across multiple corporations, they can overlap. So for each user of the system and across each tenant, and there's tens of millions of users and hundreds of thousands of tenants, we need to develop an individual behavioral model based on their previous behavior. And then I need to click. So in our case, we're using Apache Spark and HDFS to scan all the behavior being performed, like logging in or trying to export your data every week. And then based on the anomalous behavior, based on the value we've derived over the past year of behavior, we can then see if you're an outlier, we send that information to our security detection and response team to manually intervene. We can require the elevation of user credentials to use two-factor authentication or something else. Or we can block the action entirely and tell you you're out of luck. In order to make sure we don't have false positives, which would reduce customer satisfaction and drive our customers away and say that the cloud is terrible, we use both tenant aggregate and user-specific information along with a correction factor based on when it occurred, where it occurred, and what the user was doing. So if you're in your office in Dallas and you usually export all the data on Friday during the day, that's great. If you're doing it on Saturday night, that's weird. That might be a problem. Doing it from Central Asia, even more of a problem. So we have run this algorithm against both synthetic data and actual production data and found that it was actually quite effective, and we are deploying it, but due to some business sensitivity and the fact that this room might be bugged, I'm not going to go into any more detail. So that's great for maintaining security, but it doesn't help you get the right lead score for who to market to. It doesn't help you get the right article when somebody hits your website for a support question. It doesn't tell you when that big deal is going to close. To that end, Salesforce is building an AI platform to generate AI, models to generate models, algorithms to generate algorithms. We call that platform Salesforce Einstein, but since I'm not in sales, and I'll try and talk to you more about the underlying AI challenges, then the amazing benefits that Salesforce Einstein can provide you to help your customers love you, for which you should immediately talk to your Salesforce account executive. If I'm going to be shameless, I'm at least going to be positive about it. Okay, so back to AI. There's a big difference between selling forks and forklifts. There isn't a lot semantically different between those statements. They're both selling metal objects to people. But the sales cycle, the customer base, B2C versus B2B versus B2B2C, the marketing processes, they're all night and day. Yet it requires a lot of the same schemata and data shapes. You have accounts, you have business contacts, you have sales opportunities. You probably need to have a support website where people can ask you questions about billing, RMAs, and the quality issues of the metal in your fork and or forklift. How do you build a system that accurately understands those questions and automatically handles, is the customer happy or is the customer about to sue you? Since you can't look at the data and manipulate the algorithm, we need to provide an algorithm that will adapt for the particular tenant, so it needs to, in a sense, be smarter up front. Unlike a lot of other consumer-facing companies, the data, although it's similar, wildly divergent in terms of the content of what's in those articles, the opportunity sales cycle, the lead capture information. Like in the PCA example before, we have algorithms that operate at a tenant level and user level. And so for the second of my examples, I'll go into something that hopefully will be a little bit more positive. So the second example is around natural language processing. In a paper we published in November, our Salesforce Einstein research team developed a new algorithm for doing many NLP tasks at once called joint many task. Now, I didn't know I was going after the Microsoft guy. Speech recognition has gotten much better since this demo a decade ago. However, much of the analysis around NLP is for rather task-based analysis to do generally one thing. Not speech recognition from audio, but when you actually get the process. So each of the questions posed to a customer service website, you have one algorithm to understand English, and one for doing speech tagging, and one for doing semantic analysis, and one for doing sentiment analysis to know if the tweet was good or bad. These algorithms are usually purposefully trained for and used for that one task. But in a multi-tenant environment, there often isn't enough data to train the one algorithm per tenant, especially for smaller customers that only have like 200 articles maybe. So you need to generate an abstract deep learning algorithm that lets you apply a single model to tenant-specific data across multiple tasks. To that end, we trained an algorithm under the Richard Socher Salesforce Einstein team to be both very flexible and do many things at the same time. It does 5 things, in fact. You can take a look at that. It goes beyond just the standard part of speech tagging, in my next slide, to be able to do the relatedness of 2 different sentences to see if they have similar semantic content. Normally, to get this level of flexibility, you'd accept a reduction in accuracy, but our single model, trained on state-of-the-art corpi, have generated state-of-the-art results in syntactic chunking, dependency parsing, semantic relatedness, and textual entailment. So one application of this research, which is coming, but that's why I had the slide at the beginning, is to look at all the questions posed to a human call center agent in a chat window, see after that chat had happened all the knowledge articles that human applied as the solution to that article, and then when it comes in next, use it to be able to answer a similar question, but not the same question with the same article without any human intervention. So the algorithm helps define what the similar question is to a much level of accuracy than we had before, but we're allowed to train it on this tenant's, but apply it to the tenant-specific data. It's an algorithm to generate an algorithm. And so if you want more information about what the Salesforce research team is doing, go to metamind.io and read the paper. So the second example, ooh, the fonts are great. The second example is more indicative of how SAAS provides more opportunities for AI through improving data quality. Many of the advancements you've heard today involve taking massive amounts of anonymized data, using statistical analysis, taking unstructured data, structuring it, learning algorithms, and applying it to solve a particular problem. That's how we have self-driving cars, automated analysis of x-rays, speech recognition that can understand the thickest accent. There is usually enough information to smooth out the outliers and provide high-quality solutions because of big data. In business situations, that just usually doesn't happen. There usually isn't enough data to smooth out the edges, let alone get the harmonization you need to go from unstructured to structured. And the data is gathered by people who do not have the incentives to have high quality data. They aren't paid to spell out the acronyms, they're paid to make it rain and get the sales. So doing training on a per tenant basis often leads to, and just training on bad data, it often leads to bad predictions, bad recommendations, bad actions. If an individual silo generally doesn't have enough information to generate high quality results, how do you take all this fancy AI and machine learning and apply it not just to the largest customers like GE or State Farm, but also to a small one, especially nonprofits? You put your software in a multi-tenant cloud, you take advantage of the elasticity it provides, and then you let the customers opt in and then say, I would like you to use my data around acronyms to help train the model. That way, the master data can be harmonized and the algorithms can work and be democratized. So with SAAS, you now have these, that's my third example. With SAAS, you now have two things that come together. You have a series of customers that are willing to pay to improve the quality of the data and processes, and you have an ability to process large quantities of data across multiple customers because of the three clouds that were built by the three people that talked before me and Salesforce. But thankfully, each tenant is different, but since we are in CRM, a lot of the processes we deal with are all very similar and cluster around similar norms. They have relatively similar schema that allows us to run models against their data from one customer to another, so we can derive a meta model that works across multiple industries for determining which sales opportunities are likely to close. So to get good business results out of AI, you need to combine data, models, and business context. With SaaS, you're able to develop models over larger amounts of data while easily displaying them in the right business context, but you have to do it while maintaining the trust of your customers. It means asking for permission, anonymizing the data. It means developing meta models and algorithms that are more adaptable without needing a data scientist or human intervention. And it means spending time to help give the insights to the customers as they are improving their business and asking them to help give back. So multi-tenancy means that the small data for one company can become big enough data, that the small processing power for one company can become massive across tenants. That's what the cloud provides, and putting SaaS in the cloud helps do that. And hopefully now that this has not been super depressing as a conference, you can see that at least in SaaS, the AI winter is really more of an AI spring, which is very timely. So with that, I thank you, and I think we're going to a break.